Okay, so for this lesson, the law of sines, we're going to be solving our triangles and we're going to be finding all the different missing pieces. So we need to, in our final answer, have 3 angle measures and 3 side measures. So we will be using our calculator today for these notes when we're solving these triangles. So this is the law of sines. Now, we have a triangle, and I know there's not a picture here, so I'm going to quick sketch one out and to show you the relationship of each one of these ratios. So if I have a triangle and it's ABC, the capital letters are the angle measures, and the side measures are going to be the lowercase letters. So across from angle A is going to be side lowercase a. Across from angle B will be the lowercase b. And across from the C is where the lowercase c will be located. So when we go to set up our ratio to solve using the law of sines, the side length is on the top. So for example, okay, so for here, the way you would set it up is you would find side A and you would match it with the angle measure and you would do sine of that angle. And then if you wanted to find B, you would set it up with sine of capital B. And then C, sine of capital C. Now, when we go to solve these triangles, we're not going to set up our equation to solve this with all 3 ratios. We're going to choose 2 of them. So we would either match the A and the B depending on our given information, or we could do B and C or A and C. It's all going to depend on the given information. Now, so what we're going to be doing here is these are going to be oblique triangles. Keep in mind that back in geometry, we learned different shortcuts for proving triangles congruent. And those shortcuts were side, angle, side, where we could match 2 sides and the included angle. We also had a shortcut called angle, side, angle. We had another one, which was called side, side, side. We also had angle, angle, side. We also had hypotenuse leg, and we also had, let's see, we got A, and then we also had side, angle, side, angle, and side, side, side. So these are going to be the ones that we're going to use. Now, I don't know if you remember back from geometry, but I know when I taught it, I said there was no shortcut that spelled that bad word, okay? So, however, when we're given this information, either an angle, a side, side, or a side, side angle, either way, we're gonna be producing an oblique triangle, and it's gonna be our ambiguous case. So when we have the ambiguous case, what's gonna happen is from our given information, we can either form 1 triangle from that given information, 2 triangles, or no triangles. So this will be the hardest part, is that ambiguous case. When we're given this situation, an angle and 2 sides. Now, one of these sides will be the angle that's across from it. So when you see this situation occur, know that you may end up with the ambiguous case. So if it's any of the other ones, the side, angle, side, the angle, side, angle, the angle, angle, side, then it's not going to give us the ambiguous case. Now, side, 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 and side, angle, side, these last 2 here, and I think slide also, these are actually law of cosines, which is going to be 8-2. So today what we're going to focus on is case 1, and we're also going to do angle, side, angle. So we're going to be doing case 1. So the 2 examples I show you at first, or actually the first 3 examples, are going to be case 1. Then after that, Notice it's that SSA or that ASS. That's going to be my ambiguous case. And I'm going to show you where I will get no triangles out of that given information, 2 triangles, or just 1. So let's go ahead and see how this law of sine works. Now, I've taken a triangle. You may or may not be given a picture. So if you're not given a picture, you should always try to draw or sketch a rough draft of it or a rough sketch of it. So I've labeled in blue my given information. The red is what I need to find. So when you're all done, you should be able to list 3 angle measures and 3 side lengths. So if you want to make a nice organized list, so far we know that the measure of angle A is equal to 32. Angle B is equal to 81.8 degrees. I need to find angle C. I also need to find the length of A, which was given to me. Now, this also has a little mistake here. Change this, see how it's 42.9 here in the picture label, make that 42.2, make it 42.9. So side length A is 42.9. I still don't know B, and I still don't know C. So I need to find 3 missing things. Now, anybody have any suggestions on how I can find the measure of angle C without using the law of sines? Jenny?
A triangle with angles of 180 degrees.
Perfect. So she remembered that the 3 angles of a triangle add up to be 180. And I already know 2 of them. So what do you think I have to do? Beautiful. Add them and subtract from 180. So I'm going to add 32 plus 81.8. And I'm going to get 32 plus 81.8. And that's going to give me 113.8. I'm going to subtract that from 180. And I'm going to find out that my missing angle C is 66.2 degrees. Now that I have the 3 angles, and I can label it inside here, I now need to find B and C. In order to find side lengths B and C, I am going to use the law of sines. Now, what I need to do is have one of my fractions where I know the angle measure and the side across. So notice for angle A, I know the measure of angle A, and I also know the side length of the lowercase a. So that's going to go in my first fraction. So I'm going to put the side length, which is 42.9, and in the bottom, I'm going to put the sine of 32. Now, keep in mind, I'm not going to fill in all 3 fractions. I'm doing them 2 at a time. So if I want to find the measure of side B, I'll put B here. And I know that the side across, or the angle across from B, is the 81.8. So here, sine 81.8. I now have a proportion that I need to solve. When you solve proportions, you're going to multiply diagonally. So I'm going to multiply 42.9 times the sine of 81.8, and then the sine of 32 times B. So I'm going to go ahead and write that out. So sine, and it doesn't matter what you write where, so I'm going to just put my variable here on the left. So sine 32 times B is equal to 42.9, and it doesn't matter if you write sine 81.8 first or the 42.9. I now want to get B all by itself, so now I'm going to divide both sides by the sine of 32. That will cancel, and now I have B is equal to 42.9 times the sine of 81.8 divided by the sine of 32. Now, if we're not using a calculator, that's how you're going to leave your answer. However, when you do the homework for this lesson and you're checking your answers, you're going to use your calculator. So in your calculator, you're going to key 42.9 times sine 81.8 divided by the sine of 32. And you're going to get B approximately equals 80.12. We're going to round it to the tenths place, so 80.1. You need to be in degrees. Okay? To find side C, again, I'm going to start a new proportion. However, my first fraction, I'm going to use the same blue. Technically, I could use this new information I calculated, but let's say I made a mistake. And let's say I calculated side B wrong. And now I'm going to try to use it to find C. I could get a wrong answer. So if at all possible, always resort back to your original given. So I'm going to set up a new proportion to find C. So again, I'm going to use the 42.9 over the sine of 32. But this time, I'm going to put C and then over the sine of the angle across from C. So the angle across from C is what I calculated. So hopefully we did that adding and subtracting from 180 correctly. And now I will cross multiply and divide. So again, cross products. So I will multiply the 42.9 times the sine of 66.2, and then the sine of 32 times C. So sine 32 times C is equal to 42.9 times the sine of 66.2. Divide by the sine of 32. And I get C is equal to, and then I'm going to, if I'm doing in my calculator, 42.9 times sine 66.2 divided by sine 32. Once you do that, C is approximately equal to, I believe it's 74.0 something, and we're going to round it to 0.1. So 71.1 centimeters. Now, I'm going to go up here and relabel my triangle and fill in all my missing information. So on the test, what you're going to do is you're going to take everything that you just calculated and write it so it's easy for me to find. You're going to write 81.1. And these are all centimeters. And this one's 74.1 centimeters. Now, just to show you that it makes sense, and again, reaching back to our geometry skills, so if I label my sides here, I see that C is equal to 74.1, and B is the 80.1. Now, if you recall from geometry, remember the largest angle in your triangle is always opposite or across from the biggest or the longest side. So see how the 81.8 is my largest angle, and it's also across from the longest side. Then the medium size or the middle angle is the 66.2, and it's across from the 74, which is a little bit less than the 80. And then the smallest angle, which is the 32, is across from the smallest side. So these numbers that we just calculated do make sense. This will help us with our oblique and in our law of cosines to help us to make sure that our answers are making sense. Let's try one more. Now again, if you wanted to try to determine if possibly this could have been oblique or an ambiguous triangle, notice my given information here. I was given angle A, so to figure out if it's which one of these it is, so here, angle A, if I mark that with an A, then the next piece of given information was angle B, and then the next piece of given information was this side. So see how you can see it's an AAS if you're going clockwise. If you're going counterclockwise, S to the A to the A. So this is how you can see that it's the SAA or AAS. We're going to do the same thing for example 2. It'll be an AAS. So again, notice my given. Angle, angle, side. Or we could also say it's SAA. So again, this is not going to give me my ambiguous case. I'm going to solve this one exactly the same way. I'm going to add the two angles given, subtract from 180 to find missing A, angle A. And then I'm going to do the proportions to find sides A and B. So these are straightforward. You just plug it in and solve the proportion. But let's find the missing angle A first. So far I have angle B, I have angle C. I still need to find the measure of angle A. So I'm going to add 69.38. Add that to 74.08. And then I'm going to subtract that from 180. So 69.38 plus 74.08 gives me 143.46. Subtract that from 180. And I can see that my missing angle is going to be 36.54. So that's angle A. I now need to find lowercase a, side length where the A is, and the side length for the B. And again, I'm going to use my law of sines, so I'm going to set up proportions. Again, I like to use my given information, so I'm going to use angle C and the side that's across from it. So I'm going to set it up as 45.38 over the sine of 74.08. So I will find lowercase a first. So I can see A is across from this newly calculated angle. So it's important that you did that addition and subtraction correctly. Otherwise, we are going to get the wrong answer for A if we did not calculate 36.54 correctly. So I'll put in A here. And then the sine of 36.54. And now I will cross multiply and divide. So I would get sine. So when I do this product, it gives me the sine of 74.08 times A. And then this diagonal. And I get 45.38 times the sine of 36.54. I'm going to divide by the sine of 74.08. And I get lowercase a is approximately equal to 28.096. So I'm going to round it to 28.1, and it's meters. Now to find lowercase b, I need to cross multiply and divide, or set another proportion up. I'm going to use the same one, so the 45.38 over the sine of 74.08. Okay, for the second ratio that I need to set up, this time I'm looking for B, and again the angle across from B. is going to be the 69. Let's see, across from B is 69.38. And again, cross multiply. So when I do this one, I get sine 74.08 times B. And then when I do this one, I get 45.38 times sine 69.38 divide sine 74.08 and now B is approximately equal to 44.17, and then I'll round it to 44.2. And again, you can fill in your triangle, make sure it makes sense. So if I go back up, B is the 44.2, A was the 28.1, and again, the largest angle is the 74.08, and it's across from the largest side. The middle angle is the 36, nope, it's the 69.38, and it's across from 44, which is less than 45. And then the smallest angle is across from 28, and it makes sense. So again, you would write all your information. So here's the three angles, and then tell me what A equals and what B equals. And again, the units on these are meters. That is number 2. Practice one more before we get to the ambiguous case. Our next example is going to be angle side angle. Right there. All right, next one's angle side angle. Again, same thing. We're going to add the 2, subtract from 180 to get the missing angle, and then do 2 proportions to find the 2 missing sides. Okay, it's the ambiguous case that is going to be challenging, and I highly recommend you're paying attention, because that's probably what's going to be on your test. Is not this one, but the next one. But you need to understand how to do these proportions. We're still doing all of this. All right, everybody good? Let's try example 3. All right, so for example 3, notice again I have 2 given angles, so I need to find the third one by adding 18.75 plus 51.53. Add them and subtract from 180. So 1875 plus 51.53 gives me 70.28. I will subtract that from 180. And I can find that the measure of angle C is going to be 109.72. So 109.72 degrees. So now I could label it up here. So C equals 109.72. I now need to find A and B. And to find A and B, I use the law of sines proportions. So again, now normally in the other 2 examples, my angle that I used in my first fraction was given, and so was the side. This time I actually have to use a calculated number, because the only one that I have that matches with the side across is my newly calculated angle C. So this is why it's very important that you do this little calculation over here correctly, because if this angle measure, this 109.72 is wrong, then the rest of your answers are also wrong. And it'll be important that you show the work so I can see if you did make a calculation error, that you did have the correct use of the law of sines. All right, so I'm going to go ahead and set this up. And I'm going to take side length C, which is going to be the 2,798, and I'm going to put it over the sine of 109.72. And then from there, I can either find A or B. It doesn't matter which one you find first. I'll go ahead and do angle A first, or side A first, and it's across from angle 1875. Again, multiply diagonally. So sine 109.72 equals 2798 times sine 1875. Divide by the sine of 109.72. And A is approximately equal to 955.4 yards. I now need to do another proportion to find side B. Again, I'm going to use this same fraction. I'm just going to change the second one because I need to include letter B. So for this one, again, same beginning. So 2798 over sine 109.72. And then I'm going to put B over the sine, and the angle that B is across from is the 51.53. And now I will cross multiply. So sine 109.72 times B equals 2798 times the sine of 51.53. I'm going to divide both sides by the sine of 109.72. And B is approximately equal to 2327.1 yards. And again, once you put it up in the picture, it does make sense. So again, A would equal 955.4 and B 2327.1 yards. The C was given, and the C was 2798 yards. Next, we're going to look at the ambiguous case, and this is that ASS or the SSA. So when you see this given information where they're giving you an angle and a side opposite and then one additional side, 3 different situations can occur. You can actually find the measures for one triangle like we've been doing, or we could find a second triangle with that same given information, or it could actually not result in a triangle because it would be an undefined sign value. So let's go ahead. The first time we do it is going to be, we will find one triangle just like we've been doing. Now, keep in mind that when you did these finding theta and the things before, remember how we had to do the all students take calculus? And remember in that coordinate plane there were always 2 answers. So whenever you do the sine of an angle, that answer is always going to be the same as the sine of its supplement. So what I mean by that is, for example, if I said, find the sine of 30 degrees. Find the sine of its supplement, so 180 minus 30, the sine of 150 and the sine of 30 give you the same answer. Okay, so what we're going to be doing here is finding the supplement to see if it would form a triangle. So if you remember, sine is going to be y, and the y value on your unit circle where it's 30 degrees is 1/2. So this is how you would find this. So remember, you're all students take calculus, and this is how you're going to know that there's two answers. Now, sometimes the supplement will not form a triangle because it's going to make it greater than 180. And that's what's going to happen in this first example. So notice my given information here. I didn't fill in A. Let me fill in angle A. Angle A is 43.5 degrees. Now notice this time I can't add something and subtract from 180 because I have two missing angle measures. So for this triangle, I have to use the inverse function. Remember, whenever we were looking for angle measures, we have to hit the shift and then like the sign button, and then it opens the sign -1. So this is what we're going to do on these when we only have one angle measure. We need to use the inverse functions. So when we set up our law of sines, so just so you're aware, in case you see this on a standardized test, generally what they want you to do is put your unknown in the numerator. So all of our previous proportions or our use of law of sines had A over sine capital A and then B over sine capital B. This time when we're looking for an angle measure, we're going to set it up as the sine of A over A. We would flip it. Now, technically, it's not going to modify our answer because we're doing cross products here. So you're still going to get the same answer even if you set it up this way. However, let's go ahead and set it up. So again, when I set up my proportion, I want a side and the angle that's across from it. So in my first fraction, I can set up that the sine of 43.5 over the side that it's across from. And let's say I want to find angle C. So I'm going to find the sine of angle C and then the number that it's across from, because that's what I have so far. I don't have anything with the B's yet. So then across from C is the 72 or 7.2. I'm still going to cross multiply here and divide. So I get sine of C times 10.7 equals sine of 43.5 times 7.2. I want to get sine of C by itself, so I'm going to divide by 10.7. And I get sine of C, and then is equal to this. So sine 43.5. Actually, I'm going to do this math. What we were finding earlier was there was too many parentheses involved. So what you need to do before we do the inverse is figure out what this is. So what you're going to do first is do sine 43.5 times 7.2 and then divide it by 10.7. And you're going to find out that it's going to become 4.46319186. So to find the measure of angle C, I'm going to take that number I just calculated. I'm going to hit shift or second, the sign button, then that decimal, and I'm going to find the measure of angle C is going to be rounded, and I'll say it's 27.6 degrees. Now, to find B, what I would do is I'm going to add that to the given angle, which was the 43.5, and subtract from 180. Now, but before we do that, keep in mind that there is another angle that will also give me this answer. So what I need to do is, it's the supplement to the 27.6. So this is actually triangle number 1. I can also see if there's a second triangle that would have the same given information. So what I'm going to do is I'm going to do 180 minus 27.6. I need to find the supplement angle that would also give me this same sine value. So once I subtract this, so 180 minus 27.6 is 152.4. Now, I already have one of the angles in my triangle, so I'm going to add that because I need to find out what the other angle could be. So I knew my other angle was 43.5. So I'm going to add that. And when I add that, notice the number I get is greater than 180. So as soon as I take that supplement and add it to my other given, if it's greater than 180, then I know that I don't have a second triangle. And I'm going to only focus on finishing this part of the problem. So I now can find angle B because I know angle A was given to me. It's 43.5. Angle C is the 27.6. So now to find B, I'm going to add these and subtract from 180. So when I add these, so 43.5 plus 27.6, and this gives me 71.1. Subtract that from 180. And I find out that angle B is 108.9. Now, if this would have given me something less than 180, I would have had to keep going and solve all the missing pieces for this triangle also. But because this didn't work, now the only thing I have left to find is side length B. So now I'll do the law of sines. I'll do a proportion. So I can do B over the sine of this newly calculated angle, and is equal to 10.7 over the sine of 43.5. I'll cross multiply. So the sine of 43.5 times B is equal to the sine of 108.9 times 10.7. Divide 43.5 on both sides. And I can find that lowercase b is equal to 14.7. And I can see that will complete my triangle. So my angle A and C were given. I needed to go back and find the other two missing sides and the one angle.